Well, hello folks, and welcome to my latest office hours. Today is a bit of an unusual one in that I'm going to be talking primarily about a paper that we've been working on for several years that was published today, focused on the potential for climate change to change or to shift the suitability of environmental conditions, so weather, climate, and vegetation moisture conditions for prescribed fire in the western United States. Before I get any deeper into it, I just want to double check with everybody that the audio sounds good. I'm using a slightly different setup, but nothing too dramatic, so sometimes these slight tweaks have caused problems before, but in this case, unless somebody tells me that my audio levels are way off, I am going to continue as is. So one thing I want to point out, and this will be embedded in the archive version of this live conversation, as all of these conversations are in their entirety, with some minor editing to get rid of the weird clicks and ums at the beginning, will be archived. I'll have links to the paper itself, as well as to the Weather West blog post, where I describe our findings in some more detail, and also sort of offer some perspectives, a lot of which I'll be talking about today. But I do like to give people multiple ways to consume this kind of stuff. So this is the live video version. There is also the blog post, and then of course the paper itself, which fortunately in this case is fully open access. So let's see here. Just want to check one more thing and then we'll get going in earnest, just so I can keep track of things. All right. So for the folks who haven't already seen it, the title of our paper is Climate Change is Narrowing and Shifting the Prescribed Fire Windows in the Western United States. And embedded in that is actually a lot of complexity and nuance, not only in sort of the background understanding of what prescribed fire looks like to begin with, but also in how we go about addressing this question, because it's a bit different than the kind of science that I personally am involved with on a more frequent basis, which is thinking about how natural hazards or specific extreme climate events are changing in a warming climate. This is related to the wildfire relevant components of climate change, but it is a bit different. We are essentially in this work looking at how changing climate is affecting what is effectively an ecosystem health and risk management tool, prescribed fire itself, and how that is evolving or might evolve over time. I just first wanted to acknowledge all of my co-authors in this work. Took several years to put together. Folks changed institutions. This was definitely a peak pandemic era idea, and also an idea that came into existence because, of course, in California, where many of us are based, either presently or back in 2020, really that was a terrible period for California wildfire. Just those apocalyptic smoke storms, and to be quite honest, literal firestorms engulfing communities. That sort of is something that really escalated around 2015 and really reached a crescendo, I think, in 2020 with just the unbelievable fire year that occurred, the record-shattering fire year during that season. And although we've been fortunate that this year and last year have not been nearly as intense, this is not a problem that has gone away. I know we've been fortunate to have a reprieve, both in weather, climate, and to a certain extent in luck, the last couple of years, but that won't last forever. And in that period, one of the things that we were really talking about is, okay, so what can we actually do about this? We know that climate change is making this worse, but it's not the only factor at play. There's also the legacy of forest management historically, and the total fire suppression policies we had in American forests for the better part of the 20th century, and not total suppression these days, but still close to it in a lot of regions, which essentially removes a lot of the fires that naturally would have occurred in these ecosystems and would have essentially done some natural foresting usually at a low to medium intensity. Sometimes those fires would have been more intense, but they generally wouldn't have been as uniformly highly intense as a lot of the forest fires we're seeing under record warm and dry conditions when they're occurring these days. Obviously, that's not this year in California, but that was any number of recent years in California where we saw that, and this year in particular, we're seeing these kinds of fires up in parts of the Pacific Northwest instead, where a severe drought is unfolding, but in particular in Canada, which has just seen and is continuing to see, even into October, which is extraordinary for Canada because unlike California, fire season does not usually extend well into autumn. That far north is continuing to experience a fire season that completely shatters all previous seasons in recent memory. So I'm not going to talk really about Canada today, but I did want to offer some context for why we were thinking about this. Over the course of doing this analysis, we'd already begun work on it, but last year, when the Hermit's Peak fire in New Mexico occurred, and really it unfolded over weeks, this was not a short event, it turned out that that was an event that was unfortunately originally ignited when a couple of, really a pair of one burn pile and one prescribed fire escaped under extraordinarily dry and warm conditions, record dry and warm conditions. And there was a big public outcry over this. The Forest Service essentially banned all prescribed burning on federal forest lands for a period of time last year. So this was in the news a lot. And no one really can deny that that was a very bad outcome. This ended up becoming the largest and most destructive wildfire in New Mexico history, and it was the result of an escaped pair of prescribed burns. But I think lost in that was the wider context that that was really an exceptional exception to the way things almost always go when it comes to prescribed fire, in the sense that fewer than 1% of prescribed fires become wildfires and escape their initial intended boundaries, and even fewer of them go on to become destructive wildfires that really cause serious problems. It's not completely unheard of, and so it's not to say that the risk is zero. But the real question is, what are we comparing that risk to? It's because the world we live in, the risk of something else, catastrophic wildfire, is also not zero. And if the goal, or one of the key goals of prescribed burning, in addition to improving ecosystem health and resilience, is to reduce the risk of subsequent extremely severe wildfires, and then really what we need to be thinking about is, how do we do this risk-benefit calculation? Is it saying, if there's any risk from prescribed fires and it's never worth doing them? Or instead, is the relative comparison, do prescribed fires reduce the risk of extreme and destructive wildfires to a significantly greater degree than they induce the risk of them through escapes? And I think the evidence on that point is really clear. There is actually scholarly and quantitative research on this, and it's really clear, essentially, that prescribed fires are doing a lot of risk reduction that is greatly in excess of whatever risks they might entail in terms of escapes. And that's not necessarily the public perception, which is why I want to emphasize this. Prescribed fires historically have a very good track record of being safe and effective for their intended goals. It's not 100% ironclad foolproof, but that's one of the reasons why we wanted to ask this question, is that, well, as climate change, we know climate change is making wildfires larger and more intense and likely more destructive in the American West and in other fire-prone regions globally, and so we wanted to see, well, might it make prescribed fire more difficult to implement or not? That's essentially the crux of this question, because we know that there are so many moving parts here. We know that prescribed fire is essentially widely viewed as being an effective and desirable intervention by ecologists and fire scientists and others who study this stuff and who put quote-unquote good fire on the ground for a living, who've devoted their lives to this kind of work. And yet we also know that the climate is changing in ways that is really affecting our forests and our landscapes and the kinds of fires that we're seeing. So this was and we realized that no one had looked at this in any systematic way yet for the Western US, and not really too many other places either. So this was something we really thought was an important question and a policy relevant one, given what happened last year when there was effectively a ban put in place on prescribed fire because of perceived risks. That ban has now ended, but I do think some public perception issues remain. And so I do want to dive into some of the content of the research that we've done. But again, I just want to acknowledge my co-authors in this, because I am not an ecologist or a fire scientist, but I get to work with a lot of folks who are across a bunch of different institutions. Which is, I think, only possible because of the somewhat unusual role and funding model that I have. I can spend a lot of time working with people from other institutions, and we get to choose our projects creatively. So I just want to acknowledge my co-authors in this quickly. John Abadzaglau, Crystal Colden, Christian Shive, Dmitry Kalashnikov, Deepti Singh, and Ed Smith. And this draws upon folks from across the UC system. So of course I'm affiliated with UCLA. John and Crystal are professors at UC Merced. Kristen, is now at UC Berkeley, formerly of the Nature Conservancy of California. Dmitry and Deepti are up at Washington State University in Vancouver, Washington, the farthest north of the group. And then Ed Smith is also with the Nature Conservancy of California. So this is sort of an NGO public university collaboration that I think was really worthwhile. It was a long time coming, but I'm really glad it all came together in the end. And the reason I bring that up, as well as wanting to acknowledge my co-authors, is that multiple people on this paper have actual boots on the ground experience, so to speak, implementing prescribed fires in various settings. And so this is actually, I think, really important. So there is the risk of, as somebody who is not a fire scientist or ecologist, of parachuting into a different field in a way that misses some of the nuance. And so I'm really grateful for being able to offer a lot of the perspectives. A lot of what I'm talking about right now, actually, is what I've learned from my co-authors, who are truly the experts in that space. In that vein, I did want to talk about sort of how we did this work, first of all, before I jump into the top level findings. I know this is not as succinct as just reading the abstract would be, but hopefully it's a little more interesting. What we wanted to look at was, as I mentioned, how environmental constraints on prescribed fire might change in a warming climate, but also take a step back and consider, what are those environmental constraints in the first place in the present climate, or the climate that we've had historically? To what extent is the weather and the climate actually inhibiting prescribed fire, or constraining where and when we can do it? And so to do that, my co-authors actually dug into almost 24 actual prescribed fire burn plans. So literally these documents, these written documents that are not very accessible, I will add. This actually took quite a bit of digging on their part. There is no systematic database of these. We have published the summaries of the documents that we used, so others can take a look at them. But this is, in general, this is not information that's particularly forthcoming, because it comes some from federal agencies, some from NGOs, some from private landowners, and as you might imagine, it's not easy to get access to all of these documents. So the first step was getting those burn plans and looking at the environmental conditions that were used in each of them. In other words, what were the acceptable combinations of weather conditions and vegetation moisture levels during these actually implemented prescribed fires throughout the western US? And we have a lot of examples from California, but also examples from other places ranging from the Great Basin to the Rockies, to the Front Range, and up in the Pacific Northwest. So there is distribution across different landscapes, different ecosystems. In this, we needed to create a pretty amalgamated composite index. We weren't going to be able to dig into the details, and of course, prescribed fire implementation in specific ecosystems is very dependent on the highly localized conditions on the ground, so obviously we aren't getting at all the details in this, but we wanted to create essentially an aggregate metric. We called them RX days, essentially using the RX as a shorthand for prescription, as you would in the medical world, denoting days on which environmental conditions fell into this envelope of acceptable weather and vegetation moisture ranges. And so from all of these burn plans, we assimilated sort of the median values, and it turns out that a lot of the kinds of constraints here from a weather and climate perspective we're sort of calling it the Goldilocks-like scenario. And if you think about it a little bit at the extremes, it's pretty intuitive. If you're going to do a prescribed fire, one of the goals is to have a fire that burns at high enough intensity that it actually consumes the amount of brush and understory vegetation that you want it to, and that it doesn't necessarily just smolder and produce a bunch of smoke, which nobody wants to breathe, but not really consume much vegetation. But on the other hand, you don't want to have a prescribed fire burn at such an extreme intensity that it consumes all of the vegetation, trees from root to crown on a uniform basis, and potentially becomes difficult to control, because then in that case you run the risk of having an uncontrolled or unplanned wildfire as a result, which is not a desirable outcome either. So the Goldilocks scenario is you can't be too hot, dry, and windy, which is intuitive if you want to do a safe prescribed burn, but on the other end of the spectrum, it also can't be too cool and damp if you want to have a prescribed burn that's really going to be useful. If it's too damp, you really can't ignite anything at all. Try lighting wet wood in a campfire. It just really isn't going to happen. So there is this range, and it turns out that across all of the burn plans that we looked at, there is a range, but fundamentally it's the same thing happening, where there's conditions that could be too wet on the one hand or too hot, dry, and windy on the other. And they range a bit from place to place. There's some difference between forest and non-forested ecosystems. So we do make a macro level distinction between the numbers that are relevant for forests and for everything that's not a forest in the American West. And so the whole analysis is predicated on just two different definitions. We kind of masked out on a map basis where were the forests in the West, where were all other ecosystems that are not classed as forests, and we applied the numbers differently. So that's sort of the basis for this. We looked at historical weather observations and climate observations, and so we have this range. Then we have this definition of RX days. What are the environmental conditions that are acceptable for prescribed fire? Not too wet on the one hand, but also not too hot, dry, and windy on the other. And then we apply this across the landscape, and essentially an RX day is a day that falls into that Goldilocks range. So we looked at historical weather data, found where and when on a seasonal basis and on an annual basis where we see these RX days occurring. And then we use climate model data, downscaled climate model data, to essentially take a look at how frequently this occurred or might occur in a 2 degrees Celsius warmer world. So this is a pretty moderate level of warming, unfortunately, relative to the trajectory that we're still on today for significantly more than 2 degrees Celsius. That's equivalent to 3.8 degrees Fahrenheit of global warming. Regional warming in the West would be greater than that, because for any given amount of global warming, we see about 1.5 times that amount of warming on land because the oceans are warming more slowly. So 3.8 degrees Fahrenheit of global warming translate to even more warming in the West at the point where we're sort of making this assessment. But this is not a pie in the sky extreme warming scenario, and we're also not looking way out at 2100. Our study in this case ends in 2060. So we're really looking over the next 30 to 40 years. Relatively long time, but on planning time horizons, this is not the distant future. This is something that's not all that much longer than a lot of folks' home mortgage. So for better or for worse, it's a time horizon that some people have to really seriously consider. And what we find overall in doing this is that at a background level of prescribed fire favorability, so the number of days on which it's safe and you can do potentially effective prescribed fire, at least in terms of these environmental constraints, in terms of the weather not being too damp or too hot, dry, and windy, and the vegetation also not being too damp or too dry, is that there are a lot of opportunities to be doing this. In some places, in most, essentially the entire West, there are generally at least 30 days per year where you could do this according to this RX day favorability definition. But there are a lot of places where you could potentially have as many as 70 or 80 days in a given year that would be conducive to prescribed burning. So that's a pretty significant fraction of all of the calendar days in a year. In a year with 365, if you're lucky, 366 days in any particular year, if you have 70 or 80 of those days that would be conducive to doing these kinds of ecological restoration and risk reduction type interventions, that's a lot of opportunities potentially if you're going to leverage them. Are we actually leveraging them? That's a question I'll get to a bit later because we don't look at it directly in our study. But the point is that most places see a lot of opportunities, and in most places there are some opportunities, at least in every season, although depending on where you are in the West, it does range. There are some places where winter actually has the greatest number of days that are favorable for prescribed fire, but in a lot of other places it's often from about mid-spring to mid-autumn, including the summer. So it is the warm season. It is, importantly, also then the wildfire season, when a lot of these prescribed fire days are occurring, at least historically. That changes a bit in the future, so I'll talk about that in a moment. One thing that's interesting is that some of the places in the West that see the fewest historical number of days favorable for prescribed fire are not the hottest and driest parts of the West, but are actually the coolest and wettest parts of the West. And this includes some places, for example, in the Pacific Northwest, in the Olympic Mountains or west of the Cascades, where there is a lot of rain that occurs and often a lot of snow down to even lower elevations in some years, and when you tend to see rain distributed over a longer period of time during the calendar year. So you can get rain occasionally into late spring and summer, even in the coastal Pacific Northwest. That's much less the case, for example, in coastal California. So up there is where historically there were actually the fewest number of prescribed fire days, not because it's too hot and too dangerous to burn, but simply because the vegetation and the weather are just too damp and dark a lot of the time. So that will play into the changes we see that I'll discuss in a moment, but I did want to emphasize that some of the places with the fewest number of opportunities are actually because historically it was cool and damp rather than hot and dry. And so moving into the future, what we find is, and this is sort of the headline, there's a lot more I want to talk about beyond the headline though, is that we do see that in most parts of the West, climate change will bring about a significant decrease in the number of days that are favorable or at least acceptable for prescribed fire implementation throughout much of the American West. Generalizing on this annual average basis, the decreases are much stronger and more uniform south of about the 40th parallel. And this is interesting because I think it has something to do with what I just mentioned, which is the fact that in a lot of the hotter and drier regions, we're kind of at the upper side of the envelope of what is acceptable for, according to our current definitions and current burn plans in the real world, because it's already pretty hot and dry and windy much of the time. So there are some days that fall within the Goldilocks range, but there are a lot of days already that essentially end up above it. And if you have a warmer and sometimes drier climate, you push yourself above the upper end of that acceptable envelope in these hotter and drier places, and therefore you lose a lot of potential prescribed fire days in these places. I'm sort of generalizing again. If you look at the map, and you can see the map both in the blog post and in the paper itself, this is happening. This is much stronger effect south of about the 40th parallel. So this does include, unfortunately, most of California, southern Nevada, southern Utah, southern Colorado, and then essentially all of Arizona and New Mexico. Farther north from there, though, the annual average trends are a bit more mixed and weaker in general. So not nearly as strong in either direction as in the southern tier of the western U.S., but up in places like the Pacific Northwest and the northern Rockies, we actually see a mix of pretty small changes, modestly decreasing prescribed fire days, but also a few places that even see a slight increase in the number of prescribed fire days in a warming climate. And I think a reason for this is partly because those are the places that historically were more constrained by conditions being too wet and cool for prescribed fire much of the time, and so warming and at least occasional drying then pushes us increasingly into this Goldilocks range from the bottom end. So we were below the bottom end of the range a lot of the time, and some of those days end up getting pushed right up into this acceptable window. So the same sorts of changes potentially in the northern tier of the western US have the opposite effect on prescribed fire days as those changes in the southern tier of the western US. And it's also worth pointing out that these climate model simulations that we're using for the future suggest that the changes in the West will not be uniform. Not all of the West is expected to get drier in a warming climate, at least on average. In fact, the Pacific Northwest and northern tier are expected to get considerably wetter for much of the year. Not necessarily during fire season so much, but at least in the winter and spring months, the Pacific Northwest and the northern tier of the US might see more precipitation. They will be warmer, so that's something that's true essentially everywhere. But we expect to see some wetter conditions across the northern tier in general and drier conditions across the south. So in other words, we expect that the existing north to south contrast in essentially in hydroclimate will get stronger in a warming climate across the western US. So that's a bit of a story for another day, but it does, I think, help explain why we see much weaker decreases and even some local increases in the annual average of prescribed fire favorability in the northern tier versus the southern tier. The seasonal analysis, I think, is even a little bit more interesting because the changes in summer and spring across much of the West in particular are much stronger than during the rest of the year. So we see very strong declines in spring and summer prescribed fire days in many regions, and in particular in parts of the Southwest, including northern New Mexico and Arizona, but also parts of central and southern California. And this does especially include the southern Sierra Nevada, which was a little bit disappointing to see because that's a critically important region for this, and also the central and southern coastal areas of California. And here I'm being pretty generous with my definition of coastal. I'm really talking about the whole swath of land within about 50 miles of the coast, from the northern San Francisco Bay Area all the way south to the Mexican border. That's really the part of California where most of the population lives and where there is a lot of wild and urban interface fire risk. So we do see very large declines in the number of days that fall into this acceptable Goldilocks prescribed fire day range in these highly populated areas that are prone to wildfires. So that's a pretty significant finding unto itself. But the decreases, interestingly, in autumn are smaller than during the summer. They're still there across most of the West, so we still see decreases in autumn as well, but they're not quite as extreme as spring and summer. But then in winter is where things get really interesting, because in winter what we see is broadly across the northern tier of the western US are weak to moderate increases in the number of prescribed fire days. Whereas across the far southern tier, we continue to see strong decreases. So in the southernmost parts of California, Arizona, New Mexico, we pretty much see those decreases all year round. But in the rest of the U.S. the rest of the western U.S., and this does include the northern third of California or so, we actually expect to see either no change or an increase in the number of prescribed fire days that might occur in winter. And this is, in most places, not the time of year when prescribed fire is traditionally done. And that's partly because of staffing issues. So a lot of the prescribed fires that are done these days, at least as implemented by agencies, so the Forest Service and CAL FIRE and the National Park Service and a bunch of other entities, they tend to be done during fire season because that's when a lot of the fire suppression folks are on staff. And a lot of the wild and fire people who work for these agencies are seasonal workers. They're let go during the winter. They do not have permanent full-time roles in these jobs. And so a lot of cases, they just aren't going to be available in winter to do this. And so this is a logistical challenge, but it potentially presents an interesting opportunity if we can shift staffing and funding and policy priorities to have a more year-round fire and land management kind of service in some of these sectors that isn't only aimed at suppressing wildfires. We will still need that, unfortunately. That is a reality of the world we live in during fire season, such as it is. There's already arguments that fire, what does it really mean to have a fire season when you can, at least in some years, can get fires year-round? We still have seasonality to fire activity, though, and so I think that's still a fair way to classify it. But would it make sense anyway to have year-round staffing for these agencies and task them more generally with not just with suppression, but also with preventive work, including prescribed fire, and also perhaps have some folks who are fully dedicated to it, not having to resource share to the same degree. So this is getting a little bit into the policy world more than in the physical science world, but it's an interesting, pretty directly policy relevant thing that arises from what the physical science is telling us about changes in the seasonality of prescribed fire. Now, one thing I want to talk about is whether or not climate is even the primary constraint for doing prescribed fire in the first place, or whether it might be in the future. And I think this is an important consideration because, as many prescribed fire advocates will point out, and this includes folks who are on the academic science side of things, so fire scientists, ecologists, and also practitioners of various forms and various agencies and entities, we don't do nearly as much prescribed fire as we could be, and probably not nearly enough as we should be, if we really wanted to tackle the underlying challenges at the right scale. And so really the question is, okay, well, if even assuming we lose a significant number of prescribed fire days, and according to our research, even on a 2°C warmer world, 3.8 degree Fahrenheit warmer world, by the 2050s or 2060s, we could well see a third or fewer, so essentially over 30 to 40% decreases in some places of the number of days favorable for actually implementing prescribed fire, which is a big decrease, especially in places like coastal California or Arizona or New Mexico. If we already only use a fraction of those days that are available to us at baseline, would it still be possible to increase the use and the implementation of prescribed fire, even as climate change constrains our windows of opportunity for doing so? In other words, if we got more efficient at using those days that are available to us, could we still ramp it up, even though climate change is squeezing us on both ends? And the math seems to suggest that the answer is yes. It's one advantage of the low-hanging fruit that already exists, of the bar being so low to begin with, that we could still significantly improve the situation even if there's a large decrease in the number of days overall. The key, though, the caveat and the challenge, is that we're going to have to be more flexible about how we do it. We're going to have to be able to be nimble and to have year-round implementation. And so that's going to require policy changes and staffing changes and public education, because there is still a lot of fear surrounding fire. There is still a lot of fear surrounding wildfire. Understandably, I mean, it's been a pretty terrible decade for California fire. Although keep in mind that this year and last year are also years in the present decade in California that have generally, with of course localized exceptions, not been bad fire years, that have not resulted in weeks on end of these fire sieges and these smoke sieges across the highly populated parts of California. So even in a decade that is by far the most destructive and active wildfire decade in California's modern history, we still have some really quiet years. And this year in particular, 2023, is a year where we potentially could have done a lot more prescribed fire than we did. In fact, John, our co-author John, actually went ahead and implemented the study methodology for the data for this year to date. So really for this spring all the way up through August, which is when we crunched the numbers, when the data was available. This isn't part of the paper, but you can see the map posted on the Weather West blog post. Thanks, John. But really what it tells us is that this year, there were essentially a very large number of days that would have been favorable for implementing prescribed fire across much of California. And in fact, some of the places in California that did not see an increased number of prescribed fire days this year were because conditions were too damp. So it wasn't because it was too dangerous to implement too hot, dry, and windy this year, but in places like the High Sierra, it never dried out enough to have an effective period of combustion all the way through August. And that's pretty remarkable. But there were a lot of places in California that did dry out enough to have combustion that would have been toasty enough, if you will, to really achieve the desired ecosystem and risk reduction benefits, but would have been pretty easy to control. And especially because this year, there wasn't a great deal of competition for firefighting resources this season. So we didn't have huge wildfires burning all around the state and running out of firefighting resources and engines and personnel and aircraft. That wasn't the case this year. Those folks were available. And so they could have staffed these events if needed, and they would have been available just in the off chance that something didn't go right. There would have been, an army of people dealing with it immediately. So this year would have been a really good year to do more prescribed burning than has been done. And I have it on pretty good authority that although there has been a number of high-profile prescribed burns this year, and I think there probably have been more this year than in recent years, which is good, it wasn't nearly on the scale that we would really need to be doing this to keep up with all of the other risk factors that are resulting in increasing wildfire size and severity. A lot of the burns that we did this year were fairly modest. It doesn't mean that they weren't helpful, because sometimes targeted prescribed burning in your communities or along high-risk corridors can actually have an outsized beneficial impact, or in areas ecologically that are of particular interest and really need restoration, they can help too. But these weren't really landscape scale prescribed burning. That's really been what's argued is what is needed in a lot of places in the long run. And so the interesting reality is that this year is probably the most favorable year for prescribed fire we've seen in the past decade in California, and we didn't really fully take advantage of it. And it's not that surprising because of all of the implementation challenges that we've talked about, and all of the staffing challenges, although this year staffing wasn't really the main constraint, right? Because a lot of those folks who were on call for wildfires weren't busy with the wildfires to the same extent. There were some call-outs to Canada, actually, but other than that, in the Pacific Northwest, but generally speaking, this was a very manageable fire season in California so far. I don't want to jinx it, because fire season isn't over till it's over, and it does look pretty hot, dry, and windy this week in Northern California at least. But in general, it just looks very unlikely this will end up being a severe fire season. We've already had a lot of days that were highly favorable for prescribed fire, and probably will until the first widespread soaking rains arrive. Those opportunities will probably continue in pockets of Northern California, so hopefully those burns do as well. One thing that was interesting is that I had a couple of Twitter exchanges over the past week or so when there were these prescribed fires occurring in fairly visible places, so along 280 in the Bay Area, a couple on the Santa Cruz Mountains, one near Lake Tahoe. I think it was in the Tahoe National Forest, I might be mistaken there, but there were a number of ones close to places where people drive on freeways or go for the weekend, pretty visible prescribed burns. And of course, people were initially concerned that they might be wildfires, and then there was pretty quick communication from CAL FIRE and other agencies that they were not, and that these were planned prescribed treatments, prescribed fire treatments. And I saw a lot of folks commenting things like, "Oh my God, how reckless is it to be doing these prescribed fires at the peak of fire season? I mean, what the heck are these folks thinking? Don't they know that August and September are the peak of fire season in this part of the world?" Well, I mean, the short answer is yes, these people do know that. And this year, burning conditions are not extreme, have not been extreme when these fires have been implemented. In fact, as I mentioned, at certain higher elevation regions, it's literally been too damp to successfully do a prescribed burn. At lower elevations, conditions have been right in that Goldilocks range for days or weeks on end, where it's not too damp, but it's also not too dry, hot, and windy. And so those burns were done under conditions that were highly favorable for safe and effective prescribed burning. And so the point here is not to diminish people's fears about wildfires, because I understand that, there are people in California who quite literally have PTSD from lived experience in recent years. So I don't want to negate that at all. But it's also to, in a certain sense, decouple folks' fears about wildfires from prescribed fire. I think it's one of the important pieces of public education that probably needs to happen, because there are just so many misconceptions about the risks, which are generally much lower than a lot of people assume, because you don't just light these willy-nilly. There is a plan, literally a burn plan in place that only gets put into action if the environmental conditions, the weather, the climate, the vegetation dryness, actually fall into that range that was predetermined to be acceptable. So if for some reason it really were hot, dry, and windy, generally speaking, these prescribed fires don't move forward, or existing burn operations are concluded early if weather conditions change and fall out of that preferred range. So, this is something that's really important to consider, is that there really isn't a no fire future. That's neither realistic nor physically possible, nor really desirable, given the importance of fire as an element of ecosystems and as something that people have interacted with and actively manipulated for millennia. There's a long tradition of indigenous and cultural burning. And I'm not somebody who can speak authoritatively on cultural burning, and there are a lot of folks in California who can very much speak authoritatively on this, and there's been a bit of a renaissance, actually, in recent years, where there have been some interesting federal and state agency partnerships with tribal nations around California and the West to really revamp some of this burning on a larger scale, and also movements from within indigenous communities unto themselves, completely unrelated to what's going on at the agency level. So that's something else I wanted to touch on. Is there's this broader notion, I think these days the terminology has increasingly evolved towards quote unquote good fire, which includes prescribed burning as implemented by agencies, which is the focus of this paper, but it also encompasses cultural burning, and it also encompasses things like managed wildfires. So wildfires that do ignite naturally, usually by lightning in remoter areas, and are wildfires. They aren't planned per se, but they are used to effectively achieve ecosystem and risk reduction benefits nonetheless. If it's perceived that they can burn with reasonable safety and efficacy under certain conditions and in certain regions, these are called sort of wildland fire use kind of fires. They are fires that are more similar to the kinds of fires that would have occurred naturally in these ecosystems without active suppression. So good fire encompasses really these at least three and probably more types of purposeful constructive burning. But they're each distinct, and I don't want to conflate prescribed fire as implemented by agencies at the federal level, at state level, or even NGOs with what cultural burning is, which is something that is much broader and involves a much more holistic sense of place, and is literally culturally important in a way that is quite different from the way that these prescribed fires in a more formalized setting in terms of how the government or how NGOs implement it. I just want to be clear that while these things are related and share some similarities in the sense that there is always a certain Goldilocks range of conditions where realistically these things don't happen if it's sopping wet or if there's hurricane force winds and extremely tender dry conditions. They share that kind of at the extremes, but in terms of what happens in the middle and why these different kinds of purposeful burnings occur and the specific kinds of aims they're trying to achieve are not all the same, but there is overlap. And I would really encourage journalists who are out there listening today to seek out those who can speak authoritatively about the other kinds of good fire that's re-emerging in California especially, but also elsewhere, because there are some real leaders in this in California that have really come to the forefront again in recent years. Of course, there is the tradition for thousands of years prior to that being suppressed for the better part of the last century or so. But there really is a movement in that direction these days, and so please do reach out to those folks. One last thing I wanted to talk about before taking questions today is the concerns surrounding air quality and smoke emissions from prescribed fire. And this is actually something we look at indirectly in our paper, which is to say that all fires that burn vegetation, be they logs in a fireplace or a prescribed fire or a wildfire, they're all going to generate smoke, which is particulate matter, and in particular they're all going to produce fine particulate matter pollution that enters the atmosphere. Of course, burning logs in your fireplace is going to do so at a much smaller scale than a massive 100,000 acre wildfire burning at high intensity. So the volume really matters. And so prescribed fires fall somewhere in the middle of that spectrum, somewhat more than you'd have from burning logs in your fireplace, but quite a bit less still, generally speaking, than you get from uncontrolled, very large, high-intensity wildfires. But the other thing about prescribed fire smoke is that it occurs more or less when you want it to. So generally speaking, if there is an extremely stagnant air mass that essentially is trapping lots of air particles and smoke particles near the ground, prescribed fire is not going to occur, generally speaking, under those conditions, because there are air quality regulations that would prohibit it, or prescribed fire implementers would realize that, yeah, we don't want to smoke people out with these events, So that is a major consideration, is the kind of air quality conditions that are occurring in the ambient atmosphere. And we can predict that. We know meteorologically the kinds of conditions that produce stagnant air masses and high air pollution kind of conditions. And so that's another thing that is often the implementers of prescribed fire will strive to avoid. And there are air quality regulations also that guide that, especially in places closer to urban areas, although that is a bit of a patchwork. It works differently from one city to the other. So we did not include that constraint directly in our definition of prescribed fire days, but we did look separately at trends in conditions favorable for essentially stagnant weather conditions that would trap smoke particles near the ground. And unfortunately, what we see is that in virtually all seasons in all parts of the West, there's a pretty significant increase in the number of stagnant air quality condition days that would trap smoke from any source, whether it's smokestacks, prescribed fires, or wildfires. And so that may be an additional constraint in the future, at least in terms of air quality. But I will say this, if that's going to happen anyway, and we know that prescribed fires can at least be partially targeted towards days where there are better ventilated air conditions, so you don't have this stagnant air quality. And we know that prescribed burning in general, acre per acre, is probably going to produce a lot less smoke than an equivalent wildfire burning at a much higher intensity under much more extreme burning conditions. What would you rather have? Because just as there's no fire option moving forward in a warming climate, there also is no smoke option either. Really, we only get to choose, perhaps to a certain extent, the amount of smoke and when it occurs. So my vote generally is going to be for less smoke at times when we can at least have some control over the weather conditions under which they're occurring, rather than these massive episodes of extremely severe air pollution that result from uncontrolled wildfires occurring at the worst possible times. Think back to September 2020, a very different world from September 2022. Although even this year in California, especially Northern California, there was a smoke pollution episode just last week in Northern California from fires that were burning up in Oregon and the far northwestern part of the state. So long-range smoke transport, for example, into the San Francisco Bay Area. So there's going to be smoke. I wish there were no smoke. I don't like smoke. I hate breathing smoke. I don't even like it when the neighbor fires up their fire pit. But the reality is there's going to be particulate matter pollution and there's going to be smoke in a warming climate. And so just as with fire on the ground, the question with smoke again becomes, what is the relevant comparison? Because the relevant comparison is not, well, prescribed fire generates smoke. Smoke is bad, and so we shouldn't do it. The comparison really should be, okay, well, yes, prescribed fire does generate some smoke, and it's, I'd rather not breathe any. But if the alternative is much larger smoke emissions over more sustained periods under way worse weather conditions, if that's the trade-off, and to a certain extent, that probably is the trade-off in a lot of places, then again, I would vote for the more controlled, milder version of it. So it's not necessarily the question of what is the optimal hypothetical world, but what is the best option among the range of options that actually exist in the world that we live in. That is the kind of risk benefit calculus that I think we need to be doing, and that plays into how local and regional air quality regulators think about this stuff. It's different in some cases from asking folks on Spare the Air days, for example, to stop burning logs in their fireplace. That's something that most people these days who live in urban areas can do because they have other ways of heating their homes. Wood-burning stoves, for the most part, are not how people in the Bay Area or Los Angeles or any number of other cities are heating their homes in winter. So it's something that is optional to a large degree. Not universally, but generally speaking. Prescribed fire, though, it does potentially have a long-run benefit of reducing population-level smoke exposure in the medium to long term, even though there will be some exposure in the short term. And so I think that's the kind of trade-off that we need to be thinking about. That's the kind of trade-off that I would be urging air quality regulators to be thinking about, not in terms of the absolute short term as much. That's still important, of course, and it would be better if we can do as many of these prescribed fires on days where there isn't stagnant conditions in place and where the smoke isn't going to get trapped near the ground where everyone's going to breathe it for hours on end. But on the other hand, it really is a question of trade-offs, and not the best possible world, but the best world from among the options that we've got available to us. And so that's sort of what I wanted to point out about the air pollution and smoke side of things. There is even work out there, by the way, from folks up at the University of Washington and my Stanford colleagues suggesting that the smoke from prescribed burning is actually actively less harmful than the smoke from large wildfires. And it's not entirely clear at this point whether because the smoke itself is less toxic, which is possible because if you burn at a lower intensity, you're actually potentially changing the chemical composition of the smoke plume. And also, during prescribed fires, generally speaking, you're not burning stuff other than vegetation. In wildfires these days, we're burning an awful lot of structures and vehicles and hazardous materials, unfortunately, that are in populated areas when these fires burn through communities. So in addition to being a tragedy for the communities, the chemical composition of those smoke plumes is not just from burning trees and brush and grass, it's also from gasoline and from plastics and from batteries and things like that. And so there is a plausible reason why the chemical composition of a much higher intensity smoke plume that contains a bunch of potentially hazardous materials burning as well could be quite different from a lower intensity fire, but exclusively burning carbon-based vegetation, essentially. And then, of course, there's the question of volume. If you're just getting much less smoke from prescribed fires versus uncontrolled wildfires, that might be another piece of it too. But the research into that is still ongoing, but there's some really interesting angles, I think, to pursue on the air pollution side, which is going to become really important because, unfortunately, we did find pretty strong evidence that the number of stagnant air quality days will increase in a warming climate. And that's not just going to be a problem for prescribed fire or wildfire smoke, by the way. That's going to be a problem for all kinds of air pollution. See other work by some of my Stanford colleagues who have gone on to work elsewhere into the changes in air stagnation in a warming climate. There's a growing body of research out there on that front as well. So I did want to actually leave time for questions. So what I'm going to do is take a sip of water and start scrolling. So if you hear me stop talking, that's not because I've left. That's not because your sound is frozen. By the way, the quality, at least in the continuity of the connection, seems pretty good. I can still see the video is a little bit lower quality than I'd like, but as far as I can tell, there have been no audio or video interruptions, which definitely I think is more important. So just give me a moment here. And again, I'm going to post links embedded in the final edited video that'll be up in an hour or so once this is done, to the paper, to the blog post. You can find the blog post pretty easily right now. It's on the homepage of weatherwest.com. So you can navigate to that directly. It'll be there until I write a new post, and then it'll just be archived. And I'll also post a link to the paper itself because, as always, I try and at least write introductions and conclusions and abstracts and titles that are broadly accessible even if you don't want to read the rest of the paper and aren't a scientist. So I write my abstract and, to a large extent, introduction and conclusion statements in these papers as if it were a blog post. In fact, you might notice that I've copied some material directly from the paper into my blog post with minimal editing. Because the way increasingly the way I write for scientific audiences, at least in the contextual parts of scientific papers, is very similar to the way I'm talking to you right now. You might not want to go into the methods section and potentially the results section if you don't want to deal with the technical details, but at least in the introduction and conclusion, you might actually be able to glean some insights. All right, let me see here. Okay, there aren't too many questions, so if you've been holding back, feel free to add them. I'm going to start at the beginning, but feel free to add them and they'll start showing up as I scroll down. So there's a question from Rachel. I think I've briefly addressed this. Rachel has a few questions. I'll start with the first one. How does the changing climate affect the safety of prescribed burns to prevent massive forest fires. So as I mentioned, that the baseline safety of prescribed burning is pretty high, with the caveat that there have been a couple of events that have escaped and gone on to do a lot of harm. So the Herman's Peak example is one of them. There have been a couple of other examples globally in recent years that were prescribed fires, and these are often longer burning prescribed fires, so it's not that these events are ignited day of and go nuts, but often it's the conditions that take place days or even weeks later. These things flare back up when personnel are gone. These have been incompletely extinguished for whatever reason, and then under more extreme weather conditions later they take off. So that is an important consideration. One thing that we looked at in the study, and I haven't talked about it yet, but it is talked about in the paper and the blog post, are what climate change is doing to so-called 1,000-hour fuels. 1,000-hour fuels, so you might hear about 10-hour, 100-hour, 1,000-hour fuels. Ultimately, these are really just references to vegetation of different diameters, either dead, down, or inactive vegetation seasonally that is present on the landscape. 1,000-hour fuels really just means it's essentially a log on the forest floor that takes roughly 1,000 hours to respond to weather and climate variation. So it's not going to respond very quickly to one hot and dry day, but if you have a hot and dry month, then that kind of fuel is going to dry out. It won't do, and likewise, 1 to 10-hour fuels are things like grass and very light brush, where you might even have dew in the morning, but if it's hot and dry and windy the rest of the day, that grass could potentially dry out even just over the course of the day. So that's what 1 to 10-hour fuels would look like. But we did specifically look at the drying of 1,000-hour fuels. So these big, heavy fuels, think like dead, down trees on the forest floor or something like that. Because this is the kind of fuel that has that has essentially allowed some of the wildfires we've seen in the Western US and Western Canada, this year is unfortunately a dramatic example of that up in Canada, to become so extremely intense, because it literally adds a tremendous amount of fuel for the fire, and these things burn for a prolonged period of time, sometimes with a lot of intensity, literally with a lot of BTUs in terms of thermal intensity. And so they tend to increase fire behavior, they increase the likelihood of seeing extreme exotic fire phenomena, and they also tend to generate more embers than, say, a fire burning through grass. And so if you have windy conditions and you have a bunch of 1,000-hour fuels that are fully engulfed, they might send an ember storm downwind for many hours and potentially spot over control lines or hop over rivers or roads or something. And so that's that's why they're risky. And what we find is that unfortunately, in a warming climate, 1,000-hour fuels are going to get a lot drier virtually everywhere. And this was a little bit surprising to me, actually. I kind of expected them to get a lot drier in Arizona and New Mexico, most of California, and maybe the Southern Rockies, but maybe less so the Pacific Northwest, because it's actually supposed to get wetter up there on average. But interestingly, for most of the calendar year, 1,000-hour fuels also get considerably drier up there. And I think what that's really telling us is that the net effect of climate change on things like the evaporative potential of the atmosphere, the thirstiness of the atmosphere, if you will, even in places that see more rain, they're also going to see more intense evaporation, and at least in some seasons, and this is likely to be true in summer and in some autumns, even in the Pacific Northwest, that increasing evaporative demand will win out, and you will be able to, over the course of a couple of really, really dry months, at least during the drier years, dry out those 1,000-hour fuels to pretty extreme levels that are essentially historically unprecedented. And that is in fact exactly what we've seen in recent years across parts of California and parts of, in particular, northern Arizona and New Mexico, including, by the way, where the Herman's Peak fire escaped. This was viewed in the Forest Service report, the After Action report, as being a primary contributing factor to why that particular fire went on to become a catastrophic wildfire, was the extraordinary and record-breaking dryness of these 1,000-hour fuels. So that is going to be a consideration in terms of safety, and I think one piece of advice for folks performing prescribed fires, including agencies and really anyone else putting good fire on the ground, is that especially in places where it's relevant. And you don't even have 1,000-hour fuels everywhere, by the way. If you're burning in grassland or in sagebrush territory in the Great Basin, there are no 1,000-hour fuels, so this may not apply. But in forests, or even in places that have patches of forests, or even just clumps of trees along creeks and watersheds in much more sparsely vegetated regions, this is relevant because those 1,000-hour fuels historically might not have been so much of a concern at certain times of year because they'd be quite damp. That likely won't be true in the future, potentially even in winter sometimes. And so this is going to be a challenge. But it's also something that can be overcome with awareness. And I think incorporating 1,000-hour fuels into as many burn plans as possible is going to be important. This is something I actually mentioned back when the Marshall Fire occurred in Colorado back in December of 2021. That was one that hit very close to where home is now. We were right in Marshall Canyon a few minutes before it started. And there, it was characterized by a lot of news stories as a grass fire that became sort of this urban conflagration. And while there's truth to that, it actually started in a region that has a few hundred acres of pine forest, and where there was an extensive amount of dead and down pine trees. There was some tree mortality in that region. So even though it may have started as a grass fire and it may have ended as a grass fire, in the time right after it took off during that extreme wind event, even though it was not primarily a forest fire, it ran through a forested area with a large amount of 100 to perhaps 1,000-hour fuels. And I think this was missed by a lot of folks. I don't know if anybody's really looked at this, but just based on witnessing what unfolded personally and knowledge of the area, I think there's a pretty good chance that as it made that initial run in the first hour of the fire through that wooded area, that it generated an insane amount of embers that just created a huge ember spotting problem downwind. And again, the winds that day were anywhere from 80 to 100 miles an hour, so perhaps it wouldn't have mattered. Perhaps the conditions were just too extreme after a record hot and dry fall and 100-mile-an-hour winds. There is a limit to what you can prevent, I suppose. But I think that that's relevant. I just wanted to highlight that 1,000-hour fuel component. It's of course relevant in the middle of a dense forest somewhere, particularly a forest with a lot of bark beetle or drought mortality. But it's also potentially relevant if you're talking about wildfires or prescribed burning, even in areas where there are only pockets of trees or heavy down vegetation, because in those contexts, even just one pocket that can really cook off quickly and send a huge ember shower over your control lines, that could be a problem. So that was one thing I wanted to highlight. But I did want to come back and reiterate that, again, even under these extreme drought and climate change conditions of recent years, prescribed fire still has a track record of having fewer than 1% of the time anything going wrong. And again, the counterfactual is not what would happen in an ideal world of a very low risk of prescribed fire escapes versus no risk at all. The question is, what are the risks posed by prescribed fire relative to the risks of the wildfires they're preventing and the benefits that you get both to ecosystems and from the reduced risk of catastrophic fires? And as I keep emphasizing, as my colleagues I'm sure will emphasize even more strongly, it really is clear that the balance pencils out in favor of prescribed burning. Even though the risks are not zero, they are very low, and they are lower in particular than the risks of the wildfires that might otherwise occur if we don't do that prescribed burning and use other forms of good fire that I talked about earlier. All right, so I'm going to keep scrolling down a bit here. So there's some questions coming in. This is good. There's a question from Bill, which I think is interesting. Doesn't the fact that fire experts, or that experts who have devoted their careers to fire as a forest management tool, imply some bias towards fire as a forest management tool? Well, as a person who does not fall into that category, I'm not. I may not be the best person to ask, although maybe you could argue under that framing that I may be a better person to ask than somebody who is more deeply enmeshed in it. But I think, this is always going to be true of any endeavor, right? Is that, to a certain extent, any individual is an expert in a certain range of things, and so they're going to be focused on talking about certain things. I don't think anybody I know who works in fire or ecology or in prescribed fire space thinks that it's a silver bullet kind of solution by any means. It definitely isn't. I think it's very clear that it is not, because A, you can't do an infinite amount of prescribed fire, and even if you did, you'd still have wildfires, you'd still have downslope windstorms, you'd still have severe droughts, particularly in a warming climate. So it wouldn't solve those problems, and you would still have issues. But it would really chip away at a lot of that risk. And we know that today, in a lot of parts of the West, the American West and probably Canadian West as well, there's less fire than there would have been in the pre-colonial, pre-development era, pre-total fire suppression policy era. And that's partly because there would have been natural lightning-ignited fires that would have burned pretty extensively, because no one was going to put them out. They'd burn until the snow arrived in a lot of places the following winter. And because there was active cultivation of fires by any number of indigenous peoples throughout Western North America, and really on multiple continents. This is also true in Australia and in Africa, and probably in other places as well that I'm just less familiar with. There was a lot of fire on the landscape for many thousands of years. In fact, even before people were actively cultivating fire, and that already goes back thousands of years, there would have been a lot of fire on the landscape just because of mainly lightning ignitions. So for as long as forests have existed on planet Earth, there have been forest fires, right? And there was no one to put them out, 50,000, 100,000 years ago. There wasn't really even anyone to put them out even 300 years ago, but that's a slightly different story. And so, in that sense, that putting more fire in the landscape is in a lot of ways bringing the landscape closer to what it would look like had we not imposed a lot of artificial constraints on these ecosystems. Not perfectly so, because in the end, we're not exactly emulating these natural fire regimes, nor are we emulating pre-colonial indigenous fire regimes either. Although, as I mentioned, there is a movement towards bringing that back to as much as possible in a lot of places. But I don't even folks who work in the space, I don't think it's a silver bullet solution. I've really never heard anyone articulate it as such, even very strong advocates for it. And there are the things we need to be doing, right? Because in the context of wildfire, there is the matter of the fact that there's a lot more people living in harm's way than used to. And so prescribed fire can help with that to a limited extent, but then also you have to think about policies of urban expansion and development, and in particular how suburbs are expanding into the wildlands, and how you build evacuation routes, how you build fire resilient communities, at community scale, maybe by implementing green belts, or targeted, vegetation management, or even targeted prescribed fire, and how you build individual structures to be fire resilient. So from a risk and loss perspective, that's a really important piece of the picture too. And as some folks have pointed out as well, there's also a long legacy of logging in the Western US and in Western Canada, and that gets conflated often with forest treatments. And I think even the Forest Service, to a certain extent, is guilty of this conflation, because commercial logging looks very different than ecologically targeted thinning of forests. In a lot of the Western US and the Western Canada, and again, probably in other forested regions in the world as well, I would imagine, the tree density in forests was much lower several hundred years ago than it is today, partly as a product of, as I mentioned, natural fires and cultural burning. And so these forests, in a healthy state, actually had far fewer trees per acre than we see in a lot of the American and Canadian West today. And so the problem with this is, A, that's part of the reason why we have so much fuel buildup in these forests, which we're now kiln dying with climate change and then moving a bunch of people into those zones that are at risk when they catch on fire. But it also means that when we have, one of the reasons why we had that fire suppression policies in place in the 20th and the 20th century mainly, is to preserve these forests for logging and for resource extraction. When logging is done, especially clear cutting, you end up essentially having, even when the forest is allowed to grow back or there's replanting of trees after logging, you have sort of a monoculture of trees of all the same age. So if you clear cut a patch of forest, the trees that start growing, of course, they all start growing from seeds and seedlings that sprouted at roughly the same time. So 10 years after the fact, you got a bunch of 10-year-old trees. It turns out those kinds of forest stands are actually even more flammable than the mature forests that they replace, because they're essentially, instead of having a mix of ladder fuels and mature trees that are fire resistant, you just have ladder fuels. So you have, a 10 to 20 foot tall forest where fires that are in the understory and in the grass can easily spread to the canopy. Point being, really, I'm getting a bit into the weeds here, and I'm not an ecologist or forest scientist, just want to point out that this is all what you get to glean when you work with a lot of really great folks in the field, is that prescribed fire and other targeted forest treatments that are not distinctly commercial logging can help with these things, because they bring forests back to their sort of intrinsic, ecologically ideal tree density. It's kind of, in some cases, it's a bit of a blunt object for doing so, given how much needs to be dealt with so quickly and how few options there are. But one of the goals is to do this, and we see this. You can even look at aerial imagery of large areas that have been treated by a combination of prescribed fire and ecologically thinned forests. Again, not commercially logged forests, which have the opposite problem and in many cases make things worse. But you can look at these patches of land that have been thinned and then burned, essentially in prescribed treatments, and then say a huge wildfire comes through. And in some cases, you can see these photos of, on one side of the Forest Service road, there's an area that's been treated and prescribed burned. And on the other side is a patch of forest that was not part of that treatment and was essentially at really dense forest with a lot of understory and a lot of accumulation of coarse woody debris on the forest floor. And this big wildfire goes through, and the side that was pre-treated, it looks great. A month after the fire, there's already grass and brush and new seedlings sprouting, and almost all the mature trees still have their leaves and needles, and it looks like pretty much like a healthy forest. On the other side, the whole forest is cooked, and you have a bunch of essentially skeletons. You have a bunch of trees that are completely devoid of needles. They're black from root to crown, and they probably aren't going to come back. That's the kind of differences that we often see in these before and after shots and these side-by-side comparisons. It's not perfect. It's not always going to work that way. If you have really extreme weather conditions, you might still have a high-intensity fire in the treated region. But it does mean that absent extreme weather conditions, you've got a pretty good shot of having a forest that's going to come through that fire in much better shape, be more resilient, and still be there moving forward even after that fire comes through, which of course is not just better for the ecosystem, but it's also better for any communities or resources that would have been embedded in that forest that was treated and burned at lower intensity. So no, it's not a silver bullet solution. In fact, you actually need to do a lot of other things in terms of landscape level treatments, in some cases to prepare regions to be receptive for prescribed fire in some cases. And that's something that goes beyond prescribed fire in itself. And even then, none of these things can solve in themselves climate change or the problem of people moving into harm's way. So there's a lot of moving parts. It's not the only thing that's relevant. But it is something, and the other thing I'd add is it's not relevant in all landscapes. You probably don't want to be doing prescribed fire in landscapes like high desert ones where fires were rare historically. We know that fires have devastated some of the Joshua tree stands in Southern California recently, so no one's suggesting doing prescribed fires that would burn Joshua trees because they're not really fire adapted. They don't necessarily need fire in the same way that other ecosystems in the West do. So it is ecosystem specific. There are some places where you definitely wouldn't want to do it. I know there's even some interesting debate in coastal Southern California about whether this is something that is desirable or not in chaparral ecosystems. It's less clearly it's not as obvious that it's a good idea as it is in a lot of these semi-arid coniferous forests in the West, where it pretty clearly has huge benefits. That's not going to be true everywhere in all ecosystems, and in those places it's going to be even less of a part of the solution than it would be. But a lot of the West is forest. A lot of the West is increasingly arid forest as well, and so in those settings, this is a pretty profoundly important tool. But definitely not the only one. And I think my colleagues would agree. All right, continuing to scroll down here. Ed asks, what is the post-fire prescribed fire criteria that tells us whether the burn was successful? In other words, are there ways to show that the risk was measurably reduced? Yes, there have been studies, systematic quantitative studies that show this, but I think, as I mentioned, sometimes the most dramatic examples are these side-by-side photos of what happens when a major high-intensity or a wildfire that starts out at high intensity as it enters a region and then burns through both treated and untreated areas that are otherwise identical. So they experience the same extreme weather conditions, the same extreme drought. It's not like that's changing on one side of the road versus the other, but the outcomes are just completely different. And I think that's, in some cases, the most visually dramatic examples. That might be a better question for my colleagues who, by the way, I had originally wanted to get on this live session, but just technically and timing-wise, it was just, we didn't have a lot of notice that our paper was going to be published. Today, that's a whole story about how academic publishing works, is spend 3 years writing it, spend half a year trying to get it through peer review, and then all of a sudden there's some random day on which it gets published at some point in the months following. So that didn't happen, but I would encourage, especially journalists, to reach out to my colleagues, particularly Crystal, Kristen, or Ed on that front for those quantitative or qualitative sort of anecdotes or studies for the specific numbers there. Yeah, there's a couple of comments about how the National Park Service, at least in terms of, as I mentioned, these agency-led, these sort of standardized prescribed burns, has really emerged as a leader, and I would agree. It's particular national parks in particular, so Sequoia, Yosemite, they've done some really good work, and I think, you know, the results have borne out. I mean, they haven't treated everywhere, and there unfortunately have been some catastrophic fires that have really taken out a lot of the giant sequoias in recent years, killing off, you know, potentially as much as 10 to 20% of all the giant sequoias in the world have died in fires in California in the last 5 years, which is remarkable because a lot of these trees survived a millennium of fire, and yet it was this decade that took some of them out, which is a testament to the level of intensity that these fires are attaining in a long-term context. But also there have been success stories where the treated areas in these parks have burned at a much lower intensity and the trees have survived and the ecosystems have recovered much faster than in the untreated areas. This is actually a good place to look for some of the kind of, I hesitate even to call them anecdotal because there probably is enough systematic evidence at this point, even just from these 2 national parks, to sort of make the argument that at least in these kinds of ecosystems, this is a very effective intervention. But I do think that the National Park Service, partly because there is a little bit of park level autonomy, I think that helps, is that some of the more proactive park superintendents and folks who work and implement these prescribed fires, they have a little bit more independence to do so within national park land than other entities do elsewhere. And it partly is just because of the mandate of national parks is different than the mandate that national forests have. There are way more national forest acres than national park acres in the country, and the national forests are also managed for resources, and that does sometimes include logging, commercial logging. And so those are not all, you know, having a healthy ecosystem that is at low risk of catastrophic fires is not necessarily the same goal as having large forest stands that are potentially available for resource extraction. So, you know, I don't necessarily want to make a pass judgment on that in this conversation, but I will, you know, objectively point out that those are 2 very different goals, and you're not going to achieve each goal by doing the same thing. So different approaches would apply, certainly. And the National Park Service has been doing a really good job, especially in the West in recent years. I think partly because they have different mandates and more autonomy to do good work in that sense, and to partner with other communities who are doing that good work. All right, a lot of these questions came in at the end, so I still gotta scroll down, but I think it's manageable, so let's see here. All right, here. Glad to hear the stream is working well. ultimately was not able to sign up for the fiber internet service because the home we're renting does not have grounded power outlets. So I didn't think it was worth burning the place down for a slightly better live stream quality. But I do think that my very awkward, very lengthy Ethernet cable, new router, modem, and all of that does seem to be doing at least most of the work. So I'm reasonably happy with the way this is showing up now. We'll try and get the quality up next time. And hopefully the audio quality is good. I'm using the microphone directly on my new camera today, which may help as well. So as long as the quality is good enough for these live streams, I might just use the camera. I have my fancy Rode microphone for high quality audio recording, maybe for TV and radio stuff, but perhaps for this it's easier for me to just use what I'm using today. Yes. A lot of questions that are somewhat peripherally related. We're running pretty long, so I'm going to just see what other else there is that's directly related. All right. Well, I think because we've gone now for a solid 72 minutes already, I think I'm going to probably call it a stream. But I will point out, especially for the person from Mike R. who just joined at the very last minute, who came to the stream late, don't worry. All of this is being recorded and will be available right after this is concluded. So you can, the low quality version will actually be available within seconds of me pushing the stop button, and YouTube usually uploads a higher quality version within a couple hours. So it just takes a little while. It's a pretty big video file since it's effectively a 70-minute high definition movie. I'm not sure that you really need the high definition view of my bookshelf behind me, but anyway, it will be available, and I will embed some links, as I mentioned, some key links to the paper, the blog post, etc., into that high quality version that gets uploaded a little bit later. So if you missed it, or if you want to rewind, you can do so. This whole thing will be available and archived in perpetuity, or at least for as long as YouTube allows for videos to remain online indefinitely, which so far for the life of YouTube appears to have been for the life of the company. So thank you, everybody. Again, I encourage you to check out the Weather West blog post. You can find it just right on the homepage right now at weatherwest.com. If you want to read more about the paper, there are links there to the paper itself. There are also some embedded links to other resources that folks might be interested in if you stuck around for an hour of this call. And also, there are some perspectives that are a little bit different from what I talked about today as well. So I would encourage you to take a look. And journalists, if you have any follow-up questions, feel free to shoot me an email, and I can talk with you offline. All right, thanks everybody, and see you later.